Hello everyone, welcome back. And so today the topic of our discussion would be regression on standardized variables. So we'll see what this means. So in the previous video we had seen that the units of x and y or the scale of x and y affect the interpretation of the regression coefficients. So we know that my interpretation of the regression coefficients is affected by the units of my x and y variables or the scale of the x and y variables. Okay. So is there a way by which I can go around this process, like uh, the process of my variables or my coefficients being affected by the units of x and y? So can I uh, have a method in which the units do not affect the interpretation of the regression coefficient? So is there a way that can be helpful here? So let's see. So there is a way, and this way is called the standardized variables method. So this can be avoided by using standardized variables, okay, of x and y. So we'll see what this means. So standardization is basically uh, achieved with the help of this formula. So if you want to standardize the y variable, so you'll simply subtract the mean of the y variable, the sample mean of the y variable from the y value, and divide it by the standard deviation. So you'll have a standardized value of the y variable. Similarly, you can do this for the x variable. So why are we doing this? Firstly, this is done because uh, this makes the standardized y variable, that is your yi star, free of any unit. This term is free of any unit. Okay. How? Because the unit of this value above is same as the unit of this value here. Okay. So these units cancel out. So what I get is a value that is free of any unit. So this same logic applies here also. And that is how we get rid of the units, and that is why they are not able to affect the uh, coefficients, regression coefficients that we receive, or the interpretation is such that it is not affected by the units. So we'll see how we interpret the new regression equation that we get using the standardized variables. So your x star and y star are called your standardized variables that are achieved with the help of this formula, these formulas. Okay. So the property of standardized variables, these two properties are there. So the mean value of a standardized variable is always equal to 0. Just remember this, and you must have learned this in the stats videos also, or your stats lessons also. And the standard deviation is always equal to 1. Okay. So x star and y star, they have mean equal to 0 and standard deviation equal to 1. Okay. So after standardization, it does not matter in what units x and y are used because they become unit free. So now we can use this regression equation. So yi star is the standardized y variable. Similarly, your xi star is the standardized x variable, and your beta 1 hat and beta 2 hat are the standardized uh, form of your regression coefficients. Okay, so we know that beta 1 hat is a constant term, so its standardized form will be equal to 0 because if you be subtract this value, okay, so this value is always equal to this value itself. Okay, the mean of a constant term is equal to the same uh, value of the term. Okay, so this term becomes 0, and that is why we can skip this part, and we are left with this equation wherein yi star is equal to beta 2 star xi star plus ui star. Okay, so how do we interpret beta 1 star and beta 2 star? So if the standardized regressor increases, okay, say suppose xi star. Okay, it is the regressor. So it increases by one standard deviation. Okay, on average, the standardized regressant, this is your yi star, increases by beta 2 star standard deviation units, as you can see from this equation. So if xi star uses by one standard deviation, your yi star on an average, so expected value, so this becomes 0, then increases by your beta 2 star uh, units of standard deviation. Okay, so this is the interpretation of this equation. So this helps us to get around the situation where the units affect the interpretation of my regression coefficient, this method that we have learned here. Okay, so advantage of this equation. So if we have more than one regressor, okay, so if we have more than one regressor, it means that basically this makeover of the regression equation or the normal form of the regression equation, this modification we can say, okay, this modification of the regression equation where we are using the standardized x and y variables is more useful in the case of multiple regression model where we have more than one regressor. Okay, so we'll see this in the upcoming videos. We'll talk about the multiple regression model. So if we have more than one regressor, by standardizing we can put them on equal basis and compare them directly. Okay, so because each extra regressor will be affecting my regressant, okay, and the changes will be measured in terms of standard deviation, so we can easily compare. So the units will not be relevant here. So whatever changes or whatever effect of the regressor that we'll see on the regressant will be basically in terms of the standard deviation. Okay, and uh, yeah. And if the coefficient of the standardized regressor is larger than that of another standardized regressor appearing in that model, okay, so then the latter contributes more relatively to the explanation of y of the regressant than the former. So I was trying to skip this part or skip this advantage because this will be understood more thoroughly in the multiple regression videos. Okay, so just remember these two advantages, read them and just try to remember them, and we'll understand this more in the upcoming videos. So if the coefficient of a standardized regressor is larger than that of another standardized regressor appearing in that model, then the latter contributes more relatively to the explanation of the regressant than the former. Okay, so this is all for today, and we'll meet soon in the next video. Thank you.